Right, we've got this idea now it has to be normal. Does that look roughly normal to you?
No.
They're almost all the same. Does anyone know what we would call that?
I don't know. Symmetrical.
Might be symmetrical, but if you were to graph this, it would kind of look all the same across. That'd be a uniform distribution.
No cap.
No
caps, man.
And it's not perfect, but it'd be roughly uniform instead of normal. So no. All right, that's an N and not no. So no. So if we're researching bacteria that doubles in number every minute, this would take a little bit to actually draw it out, but let's say at 0 we have 1, and at 1 minute we have 2, and at 2 minutes we would have 4 because it's doubling. At 3 minutes it would be 8. Is that going to be a normal curve? Isn't it just going to keep doubling? It just keeps going up? It's never going to go back down. So it's not normal. That's what we actually would call exponential. Not normal, so no.
What if you don't get any?
Yep, talk the talk. Let's take.
Oh, we did number 3.
Yeah, no, not normal. Pay attention when we go over stuff.
True. I mean,
It was exponential. We said it was doubling every time. Okay, let's do this. We've got to get to the next lesson. This will be our homework assignment tonight. Guys, this should take 10 minutes or less. So don't take it out right now. Do it tonight for homework. You can literally knock it out during enrichment. You're turning it in tomorrow. Say again? All 5, yeah. Like one thing I will point out really quickly, especially the first 2, it's given to you right away, right? But notice how it says, in this situation, you need context with your answers. Okay? So in this situation means you need context with your answers. Okay? Yeah, the next lesson or this lesson? Yeah, the next lesson, yeah. Okay. One of the things, again, don't forget, because you need this definition when going into this problem. Not for this problem, but in general, what do we mean? What is standard deviation?
Typically, how far the data differs from the.
There you go. So typically, how much the data deviates or differs from the mean. Think about that in this context. When we say standard deviation, the definition for that is a typical amount that the data deviates from the mean. And I need to point this out because not all of my students are doing great at this. You have a whole textbook with notes. You should have standard deviation defined within your notes somewhere. Use your resources. Use this as a studying opportunity before we have an understanding check on Monday. Okay, we're moving on to the next lesson. Because here's the thing. Every single time, so not the talk right now, every single time up to this point, continue on to the next page. Yep. Okay? Every single time that we use the empirical rule, we had a whole number of standard deviations, didn't we?
Yes, sir.
But what happens if it's not a whole number of standard deviations away?
Something wrong, right?
Not something's wrong. We just haven't learned how to handle that yet. And that's what this next lesson's about. Because here's the thing. Let me go back a little bit and point this out. Looking here, right? I mean, is it possible that someone is 68 inches tall?
Yeah.
What about 69 inches tall? Yes? So that wouldn't be a whole number of standard deviations away. 68 would only be half a standard deviation below. 69 would only be a quarter of a standard deviation below. So we have to now know how to use what's called a z-table and how to use calculators to figure answers out when we don't have whole standard deviations. The empirical rule only works when you're dealing with 1, 2, or 3 standard deviations away from the mean, but we can have other stuff. And I will say this, the reason why we care about the empirical rule, way quicker than having to use the other resources, but it only works in those specific situations. Okay, so you need to first know how to calculate and interpret a z-score. We need to be able to use z-scores to calculate the probability of an event or the percentile of a value, dealing with percents again. And again, probability and percent, probability goes with the area under the curve. Percentiles go with percents, but they're heavily tied together. And we're going to use a percentile to calculate the value of a piece of data. So we're going back and forth. So this is lesson 3, above, below, and between the lines. It's all about z-scores and percentiles. Notice those are literally the key terms here. All right? So here's where we are. The getting started. The fuel efficiency of a sample of hybrid cars is normally distributed with a mean of 54 miles per gallon and a standard deviation of 6 miles per gallon. Use the mean and standard deviation to label the intervals on the horizontal axis of the normal curve. Determine the percent of cars that get less than 60 miles per gallon. Determine the percent of cars that get less than 66 miles per gallon, and percent of cars that get less than 72 miles per gallon. So this isn't supposed to take too long. This is exactly what we've been doing. This is just a precursor to get into z-scores. A little bit more practice for those of y'all who want practice with the empirical rule. Let's get to work.
So every single left or right.
We add 6 on right, subtract 6 on left. Yes, it's deviation.
Hey, listen. Oh, this ain't group talk?
It is.
Oh, what's up? Okay, what's up?
Yes, we're just gonna.
There was something
That's
about
good.
off-topic things I had to get my back on track, you know what I'm saying? Anyways, let's
Stop
get
there,
on
blame, just let's get to work.
That's the
So, use the mean and
standard
standard
deviation
deviation.
of 6, then go left, subtract 54%.
So we're gonna label standard deviation.
Read it one time.
Use the mean, ask yourself.
Very positive.
One is equals on the side.
Go left to right.
We're gonna label it.
The middle is equal.
Oh, yeah, it is.
True.
See, you know what? Don't even want to hear me. Wait a minute.
It'll be 6, 12, 18. We'll go by 6, right?
No, I'm really counting.
I'm just listening.
I know you're sure. Okay, no. So is it gonna go like 7, 8, 9, or is it gonna be like
Where'd you get 6, 7?
one up? Because you know, if one thing, well, the standard is way is it's gonna go by 6. You know what I'm saying? Oh. I didn't know what's over negative.
This one says for number 1, right?
I was counting like 12, and then he was like 8.
Okay, let's do 2, 3, and 4. Yeah. I mean, it's fine.
No, that's a whole different thing. Yeah. Can I have the rules?
It's a fuel efficiency of sample of hybrid
No,
cars.
Give me a order.
Less than 60 miles, that's from 60 to 36.
It's like
Right? Or is that all the way? It's past 36.
Yeah, I'm confused, so.
I don't even get 36 miles per second. They say less than 60.
But it's like a 54.
Yeah, so just 60, literally just 60.
I'm confused.
All the way.
Oh, no.
Just add it to and then the hybrid cars. They just get less than 60. So it'll be 60 all the way to the left, even past 36. It's like everything.
Oh. So like.
So 9 Yeah, because that's what I'm I'll change.
What I'm saying, it's gonna go up by 6, right?
it's anything before that,
Don't go.
and if this
Wait,
line
no.
is 50%,
It's
I don't have to
it
be
should be.
divide it.
So 54,
Oh, and
that's the
then-
mean.
So that's 150.
I would listen to Keith, well, you're not necessarily wrong, but I think there might be an easier way to do
That's
it.
54. So.
I was gonna let
Wait.
you on one side.
So 50,
Because that's the mean.
Because, yeah, what's
54 is the mean.
everything from the mean to the left?
it's like,
That's 50%,
Yeah,
right?
and it's going
So what
up
you're
by
doing is wrong, correct,
Yeah.
that's, well, I know, but like, think about it, if that's the mean, and everything to the left, that's 50%,
34.
You start.
what's between 0 and
Yeah,
1?
we saw 54.
Oh.
Yeah, 84, yeah, you count your arrows and take it, that's.
But here's the thing, what percent is in between the mean and 170? And then what's everything to the left of the mean?
I don't know what that looks like.
That's the thing.
I mean, I'm just trying to, everyone's gonna get slightly easier, yes, ma'am.
So like, okay, so we gotta figure it out. It's going up by 6.
So what we did.
Everything else is left half.
So when you
For the
say
mean
less
to
than
left is
50,
50.
So we have to have less.
well, I mean, look, I get, that's
Listen
what
to the
I'm
question,
saying. I
is that
don't know.
less?
Everything last here is 50.
Remember yesterday, we did that start, where if it's 99.
Oh,
Okay, anyways.
Y'all already?
Wait.
What's 6 below 54 then?
True,
Yeah, you
true,
already
true,
see.
true, true. I
That was-
We're not doing 1, 2, and 3,
Oh,
and
yeah,
negative
yeah,
1,
yeah,
negative
you're right,
2.
you're right, you're
Right,
right.
it's 1 standard deviation below.
Oh, yeah, you were right.
48, yeah,
So
yeah,
it's
yeah.
gonna be negative.
You were correct on the top, yeah.
And then it's gonna be.
Because remember, going to the right's adding, no, not negative.
What's happening?
54 minus 6 is 48, isn't it?
48, 42, 36.
So, yeah, I know y'all are just thinking about the 1, 2, and 3, and negative 1, negative 2, negative 3, but
Do you remember when we did that thing where we split the 30 in half? So each side is 15, you know what I'm saying?
50? Oh, yeah, you're making that harder than it has to be, but yes.
Are we including that?
Is that less than 60? That's why I asked the question. You didn't listen to the question and answer it. Yes, there's no
So it's
negatives.
just plus 13.
Is that 84.1? Very close, but that's 0.15. That's the issue. The other thing I'll point out is this, to make your life way easier, here's my mean, right? What's everything to the left of the mean?
This,
50, right? That's 50%.
one standard deviation.
Now we have to mean to 1, which is half of that 68, or what is
One
that?
standard deviation.
We already had all this.
Basically, that's 54.
That could be easier than having
So right now,
equal piece.
yeah,
I never said you were wrong. He was setting up these little pieces,
65.
which isn't bad, but you have to memorize all these accurately. Whereas you could just say, hey, I have everything to the left is 50, and I know that's 34. Does that make sense? That's what I would do to make my life easier.
Oh, wait.
So let's work on 3 and 4.
Hero.
I would just say, because we already got, right, so we add. Which is 84.
No, it said less.
We added,
97.35.
then we gotta explain how we got from minus.
Or,
It's 97.5.
It's gonna be 30. Euro. You do, are you, this is.
Who's gonna say?
What?
because you gotta add the
One standard deviation. So, that's.
On the little end part.
So 30, you just write it down. Okay, so 34.
Wait, hold on.
So 13.5.
no, not 99, 97.
Oh, that's the answer. Explain the reason.
What is this like?
97.5.
Okay. So. And what sheet around? What page around? Okay, so basically, I need you to look at my little book. This is the empirical rule. So I'm gonna.
I just knew 13 and a half. I was just trying to.
Like I was saying.
That'd be a lot of writing, saying, going from like 54 to 70.
No, I didn't explain that. I just said about stuff.
Yeah.
I just said that about 13, 5, 60, 66.
Yeah,
That's what I'm saying. Okay, now we do 72 all the way to the left.
We should have at least 2 and 3 done.
The whole thing.
Let's check our answers. I have all 3 of these up here. This is a growing and learning opportunity. So I want to point this out. Here's how I was able to figure this out maybe a little bit quicker than y'all were. Notice I know starting off what's always less than the mean, everything less than the mean.
50%.
Say again. Everything to the left is what percent? 50%, right? And so I just used my halves of 68, 95, and 99.7 to get what was to the right. And notice I color-coded it. And so I didn't write out my reasoning, but we can see it here. I have 50% always less, and then I had 1 standard deviation above, so that was half of 68 is 34. That's a total of 84%. Okay? When I looked here at the 66, that went to 2 standard deviations above. And so again, I know that 50% is less than the mean, and half of the 95% was at 47.5 for a total of 97.5%. And I did half of the 99.7 to get 49.85 here for a total of 99.85%. Okay? So please understand, you can memorize each little section if you want, but it's going to be much easier to base everything off of halves, like half of the mean, and the 68, the 95, and 99.7, and playing around with those. I'm just trying to help give you a little bit easier of a job. You can do it however you want, especially if you get the right answer, and if you can justify it, explain why, I'm good. But this is a faster way to do it. That's what I want you to see here. All right, what are your questions before I continue? Say again, I can continue, Salita, thank you. Group 3, we good, or we have some questions? Good. Group 7? We good, or questions? Good. 2, 4, we good? All 4? All of 5, we good, or we have some questions? Okay, and group 1? Good? Okay, Tori, you might still need a little bit of help, let me know, we'll talk about it, okay? Okay, so here's where we are, 3.1, determining z-scores. So we're going to talk about these z-scores, and don't let z-scores be scary. I'm going to connect it to what you already know very well. So same thing I already pointed out, when data values are aligned with integer multiples of the standard deviation, you can just use that empirical rule. But what if data value does not align with the standard deviation? So right here, let's consider the fuel efficiency of hybrid cars again. That's what the getting started was. The mean is 54 miles per gallon and 1 standard deviation is 6 miles per gallon. What percentage of cars get less than 57? Notice that's halfway to the 1 standard deviation. So that's number of standard deviations is what? If it's halfway to 1, it's what? How many standard deviations? 0.5. And we're going to use that, right? So how many standard deviations from the mean is 57 miles per gallon? It is 0.5 standard deviations away because it is halfway to 1. Okay. So for this next little part, you should have that note, but let's look at B together, at least to get started. Demetrius incorrectly estimated the percent of hybrid cars. Notice he did what I've been doing of, hey, here's 50%. All right, and then he knows that between 0 and 1 is 34%. So he said, okay, well then half of that 34% is 67%, or half of 34 is 17%. So in total, I'm looking at 67%. That is incorrect. Take 90 seconds, talk with your group, see if you can come up with a reason why. We'll bring it back together. You don't have to have a perfect reason, just a reason why.
Reason one. So. We're doing this thing where it's halfway away, so
There you're right, it's right here.
Yeah, no, it's just because you're.
Yeah, so there is an issue with it.
From there to there.
Can you not have standard deviation?
You can have the standard deviation. What can you apparently not have?
Less than 57.
No.
Is it this little guy?
No, because that's part of the 50%, right?
Oh, it sure is.
There's no supposed to happen.
It's approximately, that's fine. You can't have the 34, I'll tell you that right now.
You can't have this.
So why not?
Oh,
Well, because remember, that's 68%, right?
Yeah,
So
he's
one
not
is-
that whole 34. You shouldn't-
But here's the thing, well, but here's the 34 is between 0 and 1. And so he has half the standard deviation, so he just half the 34.
That's the point.
Right here it says
That,
54.
what is that?
0.0.
Takes 3 off 34.
What is it? Inflection.
Still have.
That's
No, look.
Okay, can I bring it back together? Thank you. I know that we're not, it's quite possible we're not seeing it, but let me point this out to you. Well, first off, let me open it to y'all. Did anyone have or find a reason maybe why Demetrius was incorrect?
No.
Madison?
Multiply half of 34 and then dividing it?
Well, 1/2 times 34 is the same as dividing by 2.
Oh, I know that.
Okay?
I didn't even go on.
So, well, Madison, think about it. 1/2, what's that fraction bar mean? Divide. That's 1 divided by 2. So when you multiply by 34, the same thing. That's what I've been doing this whole time. Up on the board. Okay, so here's the thing. We've been used to, or we're used to this point, where we take that 68% and we half it to get 34%, right? But what is around this mean that allows us to just say, okay, this is half of it? Starts with an S. It's SY. Symmetry.
Oh,
The reason why we were able to have just half that 68 is because there's symmetry, so I know half of it's here.
It's not symmetrical.
It's not symmetrical. Guys, look. You see how all of this goes up higher than this does? That's more than 17%. It's not evenly distributed.
Would that make it skewed left?
Well, no, it's not skewed left because the tail's not longer. It's just there's more percent near the mean.
sure.
There's a higher amount of percent near the mean. And so this area is not the same as this area,
Which makes it incorrect.
which is what makes it incorrect. We were only able to half earlier because of the symmetry. There is no symmetry within that one section, so we can't just half it, right?
From the mean to
So really, that's
57.
like a 23rd.
There isn't symmetry on just one side of the mean. So you can't half the percentages.
Oh, it's like a 20%, 10% kind of deal.
Might be closer to that, right? So we're about to look at that. So you can't half the percentages. Okay? So you cannot half those percentages. And I want you to think about it. We've been looking between 0 and 2 some, right? There's 0 and 2. This is 34%, right? And I believe this is 13.5%. Notice 0 to 1, is that half of the area from 0 to 2? Is 0 to 1 half the area from 0 to 2?
And this choice?
No, just in general. This is using the standard normal distribution. Look right here.
Just on the right side.
Just looking at the right side, this is 0 to 1. That's 34%, right?
Yes.
And so this is from 1 to 2. You see how those are the same lengths?
Yeah.
Do they have the same areas? No, because there's not symmetry on just one side. There's symmetry around the mean. So if you're only looking at one side, you can't just half it. If you're only looking at one side, you can't just half it. You can only do that when you're looking at about symmetry around the mean.
So that's what Demetrius did.
And Demetrius made the assumption that he could just half it when he was only looking at one side. Notice the 50% that he had on the left-hand side, golden, that was good. But he halved the 34%, and you can't do that. So here's where we learn about z-scores, okay? So we're going to wrap up with this idea of a z-score. And so here's the thing, we're going to learn about how to use both tables with z-scores and calculators. Sorry. All right, we got a good few minutes of learning left. I'm just going to end on the z-scores. So, a z-score, please listen, tells us the area, or a z-score table tells you the area to the left of that z-score. And so, remember how we just said that there was how many standard deviations for 57?
Yeah.
How many standard deviations?
Don't ask me.
It's literally in the book.
Yeah.
No.
I had,
Didn't we say it was 0.5, right? Because it was halfway. So here was 54, here was 60, it was halfway in between. Right? So the standard deviations, the number of standard deviations, oh, and it's also right here. The number of standard deviations was 0.5. When you come to a table like this, you'll notice that the tenths is vertically and the hundredths is horizontally. So 0.50, so I come down to 0.5 on the z, and this 0 in the hundredths. So the area to the left, right? This is how that table works. Here's 0.5, here's everything to the left. Everything to the left of that 0.5 is what? That's exactly it. The amount of area to the left, so area is 0.6915. That's the area to left of z equals 0.5 is that. So what's the percent, right? Because that's what we want to recognize how to do is how do we convert that to a percent?
It would be 69%, right?
So we multiply by 100%, so we get 69. Go ahead and do the 2 decimals. Right? And so that's how we use a z-score table, but this is how we get a z-score. Okay? First off, I do want to point out a z-score, all that is the number of standard deviations a value is from the mean. Somewhere on that page. Anywhere you got space. Okay. So it's the number of standard deviations is from the mean. So if I look right here at 60, how far is 60 from the mean? Okay, so how did you get that 6? By doing 60 minus 54?
Yes.
But how many standard deviations is that 60 away?
2.
The 60 I think was just 1, wasn't it? So how could I go from 6 to 1? What could I do to it? Divided by
6.
what was the standard deviation? The standard deviation I believe was 6, wasn't it?
Yes, sir.
Right, 54 to 60 was 1 standard deviation. So if I look at 66 now, right? How far is 66 from 54? 12, so 66 minus 54, that's the 12. Divided by the standard deviation gives me 2. That's the number of standard deviations.
Oh, I see what you're doing.
If you look at 57, how far is 57 from the mean? It's 3. You get that by 57 minus 54. And then divided by the standard deviation, which is 0.5. That's what we mean by a z-score, the number of standard deviations from the mean. We're going to go more into z-scores tomorrow and convert those to areas. Sorry, I went a little bit longer than I planned. Nope, go back. So this practice is technically due Monday. Not technically, it is going to be due Monday. Go ahead and start on it. Yeah, you can take a picture of it as you're leaving. Tomorrow we're going to learn more about z-scores and percentiles. Don't forget what is due tomorrow.
Homework.
What homework?
M5-30, talk to
I
talk.
believe it was lesson 2, talk the talk.
She said she was evil.
Okay? Trying to make sure it's not too many problems, but we do need some more practice with it. I need to see how you're doing with it before the test.
But I didn't get in trouble. She didn't care.
Get in trouble, bro.
You peed in your bread?
She didn't care.
Oh my gosh, that was funny. It caught me off guard a little bit.
Yeah, my friends and I used to joke about that in college. All time NASCAR. Anytime it was like super redneck.
Yeah.
Huh? I bet I missaw that. Okay. Hold on a second. I'll get it back to you. I'll fix it.
So, this homework the weekend, and this is tomorrow.
Yeah. Thank you for bringing that to me. Because what?
Like everybody makes fun of me on multiple reasons. One of them is I'm not dating appeal. One of them is I don't know.
Did you say appeal?
Yeah, like I'm not the type of